Hi students, in this second video, we are now going to talk about the classifications of matter and the various properties that molecules have. So let's talk about matter. Why does matter matter? Well, it's anything that occupies space and has mass. So in a lot of ways, you can look at all matter as Catholic. It has mass. Now, the funny part about this is that matter is governed by two things, its composition and its energy. Composition is what we will focus on for many chapters. But then we will switch to energy once we get to thermodynamics. So all matter can be put into two different categories, substances and mixtures. When we have a mixture, that means that we have more than one constituent that can be separated by physical methods. That means by just separating them piece by piece. If I have a substance, however, I cannot do that because they are going to all be identical. So when we look at this separation, a mixture has one or more. Remember, more is going to be the case in this. It is going to have more than one part that can be easily separated. Finally, if we have a substance, we just have one entity. So let's talk about mixtures. First off, we have homogeneous mixtures. Homogeneous mixtures mean that they are the same throughout, that when we try to separate them, they are consistent. Heterogeneous mixtures, however, have different parts and kind of have different locations in which they are not the same. Think of Italian salad dressing or a pepperoni pizza. If I cut into a pepperoni pizza, there is a likelihood that I'm going to get more pepperoni per slice than I would somewhere else. If I have Italian salad dressing, it separates into two parts, one being an oil layer and one being a water layer. I can shake it up, get a suspension, put it on my salad, but if I eventually let it sit, it will separate back out. When we think of substances, we have two major differences. One is the compound. Compound means that it is made up of multiple elements in a fixed ratio. We are going to build compounds over this semester. Finally, we have the elements. These are the 118 basic building blocks that we are going to use to build different compounds. Just imagine our elements as the Lego building blocks for our entire semester. We can have different building blocks. We can build different things. Those different built things are our compounds. The way to get from a compound to an element is separating it by chemical methods. This means that we would have to do a chemical reaction. So how can we then look at the interaction with energy? Well, it's very simple. Converting from one state of matter to another is probably one of the most important processes in chemistry. I know it keeps your drinks cold on a very hot day. It's how we can go from carbon dioxide, solid, dry ice, to that really nice fog-looking material that is carbon dioxide for Halloween. But the reason that these substances change is by the amount of energy that is put in. For a solid, it has very little energy. It is very consistent, and the atoms are at very predictable locations called lattice points. For a liquid, we have gone and loosened up some of the restriction. That's where the fluidity comes from. But they still have an attraction that they want to stay fairly grouped together in the liquid phase. But finally in gas, we'll have broken those intermolecular forces, and they are now to freely move in unpredictable positions and any way that they want. We are going to talk about each individual property of these phases later on in the semester. But as you can see, the composition of all three of these species are the same. It's their difference in an energy that is changing their physical state of matter. This is a major change. So let's look at the three states of matter. If I were to go and take a block of ice, we can all agree that ice is a solid water sample. Notice that our solid has very predictable points, all of those interacting with the molecules next to it. We will talk a little bit about those interactions in Chem 120, and we typically call those the intermolecular forces. But if I go and put this hot poker onto that block of ice, two things happen. One, a certain amount of the molecules are going to get all of the energy it can. It will break those interactions and it will immediately turn to steam. And that is how we get the gaseous state. To go from solid to gas is sublimation. And as you can see here, we have some of this ice immediately turning to steam. However, some of the ice is going to just get enough energy to do one phase change, and that is going to the liquid form. So we are going to weaken that rigidity of the solid. And as you can see, some of the ice melts into liquid water. Every species that you see in this picture is still water. We have not broken any bonds. We have just gone and broken the intermolecular force interactions and the rigidity that is caused by that energy and interactions between molecules. We have not changed its chemical composition. So let's look at some physical and chemical properties. A physical property are those that can be observed and measured without changing the composition of a substance. We just saw one of those. Many things that can deal with this are color, density, conductivity, which is going to be how well it conducts electricity. And there are such things as malleability. Can we put it into thin sheets? And other different properties that you are going to experience, not only in the laboratory, but over your chemical career. The fun ones, however, are the chemical properties. These are the ones that can only be observed during a chemical change and reaction. Probably the best well known is going to be combustibility. I will show you this by a demonstration video of exploding balloons. Then we have food digestion. If you were to put food into your body, what you put in does not come back out the exact same way because we are breaking that species down and taking the parts that we need for our metabolic processes. So let's look at a couple of differences between physical and chemical properties. If I'm making aluminum foil, I can take aluminum metal and get it into very thin sheets. This is malleability, and this would be a physical property. However, if I start thinking about heat released in a reaction, if I'm burning something, whether it's a log, a metal, some type of other compound, that is a chemical property because we are altering its chemical composition and we are forming new things like CO2 or other various items. So let's talk about changes now. A physical change does not alter the composition or identity of the substance. So in this case, we saw this with the ice melting, even dissolving sugar in water. If we are to dissolve sugar in water and make stuff like sweet tea or lemonade, the sugar stays intact. If we were to go and evaporate all the water, the sugar would stay in the container. We have not changed the chemical composition. A chemical change, however, is when we change the identity of the substances involved, we break bonds, we form new ones, the chemical rearranges. So in this case, we are going to burn hydrogen in the presence of oxygen, and we form water. We are breaking the hydrogen-hydrogen bond, we are breaking the oxygen-oxygen bond, and we are now forming two new bonds with oxygen and hydrogen for each molecule. This is a chemical change. So the other type we can look at this for properties is what we call extensive and intensive properties. An extensive property of a material depends on how much matter we have that is being considered. Certain extensive properties include mass. If I have more of a substance, that means I have more mass, and that's an extensive property. Length. If I have a piece of foil that's longer, I have more of it, so that's an extensive property. And finally, volume. A bigger volume of something, whether that's water or another liquid, means that I have to depend on how much is being considered. The opposite of this is the intensive property. This is a property of a material that does not depend on how much matter is being considered. Density. Remember that density is an intensive property because it is grams per milliliter. If I have more milliliters, I have more grams. Even though I have more mass, it's dependent on the volume, and one is analogous with the other. So this is considered a constant intensive property. Temperature. If we have a species that has more temperature or less temperature, it does not depend on the mass of our substance. And finally, the color. If I have a substance that is yellow, Whether I have 10 grams, 100 grams, or 1,000,000 grams, it is still going to be the color of yellow. So the last thing we want to do in this video is talk a little bit about the various properties that you have seen today. So the first question states, when a material is ductile, it means that it can be stretched to great lengths without weakening or breaking. If copper is made into wire for electrical purposes, what term best describes this process? So let's think about this. Does it mean it's an alloy? Well, an alloy is a mixture of metals. If I have only copper, it cannot be an alloy. So what I can do is mark that out. Let's talk chemical property. A chemical property means that I am changing its composition. Am I changing the composition of my copper? No, I am just turning it into long, thin wires. So a chemical property cannot be correct. So finally, is it a heterogeneous mixture? Well, no, because I only have copper. So finally, we get down to the last two species here. That is the extensive property and a physical property. Remember that an extensive property depends on how much of that species I have. I can do this whether I have 1 gram, 10 gram, or 100 grams. So this cannot be an extensive property because the ductile nature of a metal does not depend on how much I have. So the correct answer for this is going to be E. This is considered a physical property. So let us go and look at our last question. Which of the following represents a physical change? Natural gas burning on a stove. Well, if I have natural gas, that's methane, and I burn it, it turns into CO2 and water. I can't go back and get that methane. So this is considered a chemical change. Liquid propane in a grill evaporates because the valve is open. Well, now we have evaporation. Am I changing anything other than the physical state? No, I'm not. This is a physical change because I am changing it from a liquid into a gas. So B can be a correct answer. Sugar burning when heated on a skillet? Well, if we're burning sugar, this means that it's changing its chemical composition. So now that is going to be an incorrect answer. Rusting of an iron nail? This is actually going and taking iron and turning it into iron oxide, which we commonly know as rust. Because that iron is now binding to the oxygen, we have formed bonds, so therefore this is going to be a chemical change. And finally, silver surface becomes tarnished when exposed to air. Tarnishing is taking silver and doing a fairly similar process to what we just did with the iron, and that is taking it and mixing it with oxygen, and it starts to become a dull nature. This is a chemical change as well. So the only correct answer that we have is going to be B. In this video, we talked a lot about the different classifications of matter and the various properties. Make sure that you are able to identify our composition and our properties, because your observations in the lab are going to be so incredibly important as to helping determine what species you have and what processes you have accomplished. Have a great day.